3.
Okay, in this problem, I'm trying to find the first four non-zero terms of the Taylor series for the function f of x equals 1 divided by x centered at 2. And then I'm going to write the power series using a summation notation. So this is kind of similar to the first problem I did, but in this case it's centered at 2 and not 0. Okay, so as I did before with the formula, I broke it up in a table, and as you can see, for in each section of the formula, that's what, and each of the titles of the second of the each column is the formula. So I did my k factorial, and there you see 0 factorial all the way down to 3 factorial because I'm finding the first four. And then for my function, which is 1 divided by x, so I took the first, second, and third derivative of my functions, and so that's what I have there. And so now I'm going to plug in 2 into x to get f of x. So this would be 1/2. This would be negative 1/4. And then this would be also 1/4. And this would be negative 3/8. And then I'm going to take my f of 2 and divide that by my factorial. So this would be 1/2. And this would be 1/4, negative 1/4. And this would be 1/8. And this would be negative 1/16. Okay, then I'm going to subtract that or multiply that times x minus a, and a in this case is 2. So I'm going to do 1/2 x minus 2, 0, and then negative 1/4 x minus 2 to the first power, and that is 1/8 x minus 2 to the second power, and then negative 1/16 and x minus 2 to the third power. So once I put these all together in each column, so that should give me, for my first column, it should give me 1/2 minus 1/4 x minus 2 plus 1/8 x minus 2 squared minus 1/16 x minus 2 cubed. And this would be my finding my non-zero terms for them. All right. So now what I want to do is write a power series using a summation notation. And so this is my summation. I'm going to set this to 1. And to figure out how to calculate my summation notation, I try to notice a pattern that's going on in my polynomial. So for the first thing that I notice is that I have a negative, positive, and a negative. So it's going to be alternating. So I'm going to add that. So when n is 1, 1 minus 1 is 0, negative 1 to the 0 power will give me my positive number. If I put 2 in, 2 minus 1 would give me 1, and that would give me my negative number. And then, so that would take care of my my minus plus minus. And then I'm going to find the pattern of the fractions, and it looks like it's multiplying by 1/2 for wherever n is. So that'd be, so that would be 1/2 n. So if n is 1, I get 1/2. If n is 2, I get 1/4. And then I need to see the pattern that x minus 2 and it's look like it's increasing by 1. So we'll put x minus 2 and n minus 1. So if n is 1, that'll give me 0, which is 1. And then if n is 2, 2 minus 1 would give me x minus 2. So this would be my summation.